This is a parabola, and I'll have you know that if you're good at algebra, if you have certain skills, you can make this parabola move any way that you want it to move. For example, once you have the skills, you can tell your parabola, I want you to slide to the left, or I want you to slide to the right. You could also tell your parabola, I want you to go up, I want you to go down. You can also tell your parabola, I'd like to make you steeper, or I'd like to make you flatter. And you can also tell your parabola, I'd like you to reflect and go upside down, and become steeper or flatter upside down. And when you get the skills in algebra, not only can you do these individually, you can do all of these together. Today's lesson is called transforming functions. We want to be able to take any graph that exists and we want to be able to transform it, make it move around the coordinate plane, make it steeper, make it flatter. This is what you're going to learn in today's lesson. So before you can learn to transform functions, you need to learn this phrase called parent functions. So with all the functions we've been studying lately, each of these types of functions has what's called its parent function, and that's considered to be the simplest, most basic graph that exists within this family of functions. So for example, the linear parent function is f of x equals x. This is the simplest, most essential line that exists in algebra class. All right, the parent quadratic function is this parabola right here. It's f of x equals x squared. This is considered the simple, most basic, most essential parabola that exists. You can go do the same with the square root function, absolute value function, rational function. One thing you'll notice that all of these parent functions have in common is they all have a center or a vertex at the origin. So this line passes right through the origin. This parabola has this vertex right at the origin. Same with the square root. The absolute value, the vertex of this absolute value is at the origin. And the center of this rational function, this hyperbola, also at the origin. So in the rest of this lesson, I'm going to teach you some tricks where you could take any one of these parent functions, of these five different types of functions, and you can perform transformations. You can make them move. Now, here's the main types of transformations that we're going to look at. Make that a little bit larger there. We're going to look at three transformations called reflection, translation, vertical dilation. So a reflection is when you take a graph and make it flip upside down. Now, if you have, so we're going to use, as our example, we're going to use the parent square root function, the square root of x. Negative signs is how you can reflect any function. So let's use the square root of x as an example. So here I have my parent function, my parent square root function. You remember what that looks like. Watch what happens is I add a negative sign. If I put a negative sign in front of the square root, that's going to flip it upside down. Now likewise, if I put a negative sign inside of the square root right in front of the x, that will actually reflect it over the y-axis. That will reflect it vertically. And yes, you could actually do both at the same time if you wanted to. You could have a negative in both positions. That would flip it over the y-axis and flip it over the x-axis. So translations, this is where we can make a graph move to the left or the right or up or down. So if you add or subtract a number outside of the square root symbol, you could say at the end of the function, this is what makes the graph move up or down. A +3 would move it up 3, a -3 would move it down 3. Now, if you were to add or subtract a number inside of the square root or inside of whatever grouping symbol that you have, this would move the function to the left or to the right. Now, moving the function to the left or the right is a little backwards of what you would think. If you put a +3 next to the x inside of the grouping symbol, that actually moves it to the left. It's kind of backwards of what you would think. Here's a case where a +3 moves it left 3, and a -3 moves it right 3. That's kind of the opposite of what you might expect, but that's how translations move horizontally to the left or to the Now watch this closely on Desmos. So if here again is my parent function, the parent square root function. If I want to move it up, I can add a number to the end of your function. And that here it moved it up 3. I can move it up by 1 or 2 or 3 or 4, whatever I'd like to do. And then likewise with subtraction, if I subtract a number, like here I have a -1 or a -2 or a -3, you can see how that moves the parent function down that amount. Now, if I move my cursor inside of the grouping symbol, in this case the square root, here are the plus signs. If I add 1, it would move it 1 space to the left. Likewise, if I add 2 or add 3 or add 4 or add 5, this will move the graph to the left. If I want to get it to move to the right, I will use subtraction. Subtract 1 or subtract 2 or subtract 3 or subtract 4. And yes, you can use these together. So if I wanted to move my square root function here to the point, so it had a vertex at -3, -1, I could do a +3 inside of the grouping symbol and a -1 outside the grouping symbol. This would change the vertex so that my new vertex is at -3. It's kind of the opposite of this number, and then a -1. Now the last transformation we're going to look at, it's called a vertical dilation. So if you want to get a graph to become steeper or flatter, you can actually multiply a number at the very beginning in front of the grouping symbol. In this case, in front of the square root symbol. So let's look at this on Desmos. So here I have my parent square root function again. Let's watch what happens if we go in front of the grouping symbol here and we multiply a number. We do like a 2. Well, my curve has now become twice as steep. I can make it, I can make it 3 times as steep, or 4 times, or 5 times, as much as I'd like. Now I can also make it flatter by using a decimal or a fraction. So if I put a 1/2 in front of that, that's going to make it half as steep. 1/3, 1/4, 1/5. And, excuse that. And then the same with negatives. I can also use a negative in conjunction with this compression and flip it upside down. So here would be an upside down square root function, only with 1/5 of the original steepness. Now think back again. Let's use the square root function as an example. Back in lesson 2.2, you learned what's called the general form of all these functions. Here's the general form of a square root function. It's written like this. What's really happening is you can say that h is what is causes a horizontal translation of your graph. It moves it left or right. K is called a vertical translation of your graph. It moves it up or down. And then A is called a vertical stretch or dilation or compression by the factor of A. So with that in mind, let's do our first example. Example number 1, sketch the graph of f of x equals x plus 3 quantity squared minus 1. Now the first thing I would encourage you to do in these types of problems is write down what's called the general form of the function. So this is called a quadratic function, and here's the general form of that function. You learned this in assignment 2.2. Now the next thing I'd like you to do, I like to put the parent function on the graph. Our parent function, the parent quadratic function, is simply x squared. It looks like this. This is what we just learned at the start of this lesson. So now let's break down what's going to happen to this parent function that's going to be different once it's transformed. So I like to go ahead and, looking at my example, this plus 3 right here, it represents h. Okay, and now remember h is always the opposite of what we see. So when I see an x plus 3 inside the grouping symbols, I'm actually going to say that h is -3. H is always the opposite of what you see. Now this constant term at the end, it is represented by k. We'd say k is -1. Now with k, you take exactly what you see. I see a -1, I keep it the same. I keep it as -1. What this means is that the new center, or the new vertex in this case, of my parabola, of my transformed parabola, is going to be at -3, -1. I'm going to go to my graph, and I'm going to label that point -3, -1. This is where my new vertex will fall. Now the last thing we want to look at is this compression value, this value of A. Now with A, there is nothing written here There's nothing written in front of the parentheses. If you want, you could put an imaginary invisible 1 there. A is actually equal to 1. That means that my parabola is going to keep the same steepness as the original parabola. Now, I don't expect this to be perfect, but I'm going to draw roughly the same steepness as my parent function. What's different, though, is that my original parabola here in green, my parent function, has been transformed 3 spaces to the left and 1 space down. That's why its new vertex is right here. And let's wrap up today's lesson by doing one question off of your Canvas homework assignment. Here's question 9 from your Canvas assignment. So my advice, I would start by identifying the general form of this function and the parent function. Yeah, I have this function right here. The general form of this, what we learned in assignment 2.2, the general form of a square root function looks like this. And then the parent function is just the square root of x. The parent function, I'll draw it in green. It looks like this. And again, I'm not going to be super particular that it's perfect or anything like that. But it's kind of a sideways parabola. You get half of it. So let's look at our new transform function. Our new transform function, right here, it has an h value of positive 4. I see a minus 4, but I know that for my h value, I have to change the sign because the formula has a minus sign here. That means the opposite of. So h is positive 4. Now you'll notice here that I don't have a k value. When I go to look for my k value, there is nothing there. K is empty. It's blank. And so with h or k, if it's ever blank, if you're ever missing one of those values, you're going to put in a 0. So h is 4, k is 0. My new vertex is going to be at the point 4, 0, which is right here. Now going back to my new function, I also have an a value of 3. What that means is that it's going to be 3 times steeper than my original parent function. So starting here at 4, 0, I'm going to draw a square root function that's, 3 times steeper. It's going to look roughly like this, steeper than the original. And if you look at your choices, the answer has to be D. For one thing, D is the only choice that has the correct vertex that starts at 4, 0. So I hope that is helpful to you. Best of luck on this assignment. As always, message me if you have any questions. Take care.